The next session is a presentation on Indians in Space, Where Are We Headed? By Professor Aloke Kumar, scientist, IISc Science Communicator.
Okay, so that was a rather fiery session. So now I'll move on to a very, very different topic. But first of all, thanks to all the organizers of the PLF and for bringing me here with such a wide diversity of topics. And the juxtaposition of the topics also is rather interesting. Okay, so I'm going to be talking about Indians in space. That sort of gives away the heady topic itself. But I will start the journey with some sub-stories. Okay, the first sub-story would be about me. It's sort of a lived experience about myself, which is a very nice way of saying I'm going to pat myself on my back. So I'm a professor at the Indian Institute of Science, and I teach fluid mechanics. That's my day job. And space is something that was sort of far away from my own work area. COVID changed that. I think COVID changed a lot of things for a lot of us. For me, what it did was it shut down my lab for a very, very long time. And we had a very thriving lab, a lot of young students working day in and day out. And everything was gone, and we did not know what will happen. Right? So we spent a lot of some first weeks hoping things would come back to normal. I hope many of you probably remember your times during that time. But it didn't. And my day job was gone. I attended 5 Zoom meetings at once, but there was no real lecture to give, no real students to interact with. And that was very difficult time for many of us because the purpose of our work was sort of lost to me. But then I decided to take up a night job. If you remember, at that time, we were able to see Himalayas from faraway cities in the north. The air had cleared up quite a bit, and in Bangalore also it had cleared up. So I assigned myself the task of, I always wanted to be, I think when their kids want to become astronomers and astronauts. So I decided, I wanted to become an astronomer at one point of time in my life. Somewhere that hope had gone away. Why don't I do it now? I don't have a job anyway. So I started doing own astronomy. I self-taught myself. And by watching YouTube videos, I had a lot of optics with me back then. So I started looking at the stars. And one of the interesting things I noticed during one of my nights, and this is just on my roof taking some images, was this. This is one of my first pictures. You can see there's a bright spot at the middle of the image, and this is taken through a cloud. And at the time, I did not know what I was imaging at all. So again, I said I started at ground zero, sort of totally taught myself what these things are. And I read that these are something called nebulae. What is a nebula? Nebula is a gaseous region, usually illuminated by a star. It's filled of gas, several light years. It could be a couple of light years to hundreds of light years across, depending on which nebula it is. This particular one is about 20 or 30 light years across. And this is also called the Orion Nebula, and also known as M40 Nebula. And the great thing about this is you can see it with your naked eyes. So between now and April, if you love this particular topic, you can find yourself the Orion constellation. Below the belt of Orion, which are the 3 very distinct stars, you will see between the stars that mark the foot and the belt, there is a wispy region. Okay. In the beginning, I thought that was a star, but when I started taking photos, it didn't look like a star at all. But what it is a huge, gigantic nebula, which is the birthplace of stars. And the reason it is so bright is because there are a lot of stars being birthed in that region, and all those stars are illuminating all the hydrogen and dust clouds all around. And it is so big that you can see it with your naked eye. If you try to, just one quick hint for anybody who's going to try, it will look like a star, but when you try to focus, it will sort of disappear because it's a sort of wispy in nature, and that's your nebula. That's how you usually recognize a nebula. Andromeda does similar things, although it's a galaxy. Anyway, I was teaching myself. I'll come to the main part of the story in a second. But I was teaching myself, and over time I learned that you can do a good job of taking these images. There's a lot of image processing, a lot of computer algorithms involved, and I set up my own amateur astronomy kit on my roof, and I started taking images, and this would take a long, long time. Right? So this is also something I call the geek's golf. You just set up your instruments. Sometimes a cloud comes, you just wait, nothing to do, and it takes hours, and time just flies by. I spent a few months, and okay, so this is what I got. The photograph on the right is an expanded view of what is on the left. This is all taken from a simple DSLR camera on my rooftop with a little bit of sophisticated instrument, not a lot, very simple, and I was able to see this nebula, and all the colors that you see, these are primordial colors. These are not the green and the yellow that we see here. These are the simplest of the electronic transitions, creating a red, blue, or a green in the sky. And with your naked eye, although you cannot see that because the eye in the darkness cannot resolve colors, you'll just see it as a white patch. Anyway, it's very bright. In the center, there are stars being birthed. Yeah, sure. In the center, there are stars being birthed. A very beautiful view. So I found myself a nice hobby during COVID times, but then slowly things started getting better. Things started opening up just a little bit. Only for some important meetings you could go and do it in person. And it turned out there was some important meeting for which I was asked to give a lecture on fluid mechanics to a bunch of important people. And they said, why don't you come and give this lecture in person, not in Zoom? I was very much relieved at that thought itself. So I went. In that group, and I'll tell you who the group is in a second. In that group, there was one gentleman, and he, after lunch, we had the lecture and we had lunch, and then he said, I want to learn this amateur astronomy. Do you know anybody at IISc who does that? And so I do that. I've been doing it for some time. And he was very happy once he heard that. He said, I've been looking for someone for a very, very long time. I'm glad I found you. I'm going to bug you a little bit about all these things. I did not know how much he will bug me, because I got a call the next day saying, when can we set this up? I said, wow, that was fast. Relax, we'll do it in some time. And then I kept getting calls every 2 or 3 days, like, when can we set up? When can we set up? So I said, okay, finally I gave in, and I said, okay, let's do this. So the two of us, and I'm just going to let you know who that person was. We spent a lot of nights, again, this is during the COVID times, it has not ended yet, of staring into the skies, taking photos, and I learned astrophotography with him also. And here is a photo of the famous man who's on the left. I hope you can recognize this person on the right. We spent a lot of time taking these photos, and what we did is, after a whole year, we put together a calendar of some of our photos that we had taken together, including a lot of them by ISC students, so we put together a calendar. By the way, I have bought although the year is almost done, I have a few calendars to give away if you want. So I hope you recognize the person on the right. If you don't, there is a better photo of him. This is Group Captain Shubhanshu Shukla. He is, hopefully, fingers crossed, things go right, will be the second Indian in space soon. He is off in the US right now, training with Axiom, learning how to be an astronaut on the International Space Station. So that was quite an interesting part. I said I'll share a lived experience and sort of pat myself. So that worked. Thanks. Okay, let's move on to a slightly more heady topic now. We discussed a lot of things during our time together, and one of the things he consistently asked me is, what was India's role in space science? So tell me, and I had to read up about it. So I ended up going all the way back in history, trying to figure out what India had done and why it had done so. Now it turns out that the sky was our first clock. It's there. Your moon has a very precise timing of the phases. The sun, obviously the motion is quite precise. And that's how we found the first clock for the month and the first clock for the year. In between, you had the motion of the stars, which were also moving in very precise ways. And if you were good at calculating and you were good at math, you could figure out what time of the year it is. As empires grew in India, the need for being able to calculate the calendar became very, very important. It became important globally. But India had taken a fantastic lead at that time. We had amazing mathematicians. Right? I hope you have read about some of them. And during the Gupta period, we didn't have one or two good mathematicians. We had many. In fact, in the history books, you only appear to read of some of the greatest. He is obviously one of the greatest. I hope you recognize this sculpture. This is Aryabhatta, and this photograph is taken from Ayuka, Pune, where this is the only statue of him I have seen ever in Indian campuses. There might be more, but I have not seen them. Aryabhatta was not alone. There were many who were involved in the problem of calendar making. Now, one quick word about why calendars were so important. The calendars were important because as empires grew, it was very important to have the right taxation at the right time. It was important economically. It was also important religiously, because if the king wanted to celebrate Diwali, the king should know when Diwali is going to be there. And all these festivals are associated with some event in the sky, something about the moon or something about the sun. So you have to be able to know beforehand when is Diwali coming. Now, imagine you are an emperor and you said, oh, tomorrow is Diwali, we'll all celebrate, and everybody comes to the capital and it turns out it's not the right day. What a fool would you look. And this was actually an important problem worldwide. In fact, it was such an important problem that we had Buddhist monks from India who traveled to China and became established astronomers there. Because you needed people grounded in mathematics to be able to calculate these calendrical events. And calendar keeping was difficult. There were two problems with calendars. One is precise measurement of the stars. See, the sun and the moon are still easier problems to some extent. But calculation of the travel of the stars, which gives you all the days in between, that's more complicated. It requires precise calculation. There is another problem. The earth, you see, spins like a ball, like a top. But it doesn't spin very nicely. It actually wobbles a little bit on its axis. This wobbling is called precession of the earth. So what happens is, because of this wobbling, the stars change their positions every now and then a little bit. And this change of the star's position is very small. So for 1 year to the other year, you will not be able to know it. But over a period of 50 years, you would be able to know it, and the days would be actually off. So if today was Diwali, your calculation might show it would be 2 days later, and that would be a fiasco. So that problem became prominent. Because of this reason, you had many scholars, the top-notch scholars of that time, working on this problem of calendars. We had Aryabhatta. By the way, his original writings are not available to us. The only way we know what he wrote is because others commented on it. His original work was lost. And if you look at the way they have commented, they are not all in praise of him, just as it would be in science. Do you think when Einstein made his first prediction, everybody came together and said, oh yeah, what a fantastic theory? It didn't happen that way. People disagreed. And that's how science works. And that's exactly how science worked even in the olden times in India. People were significantly in disagreement with him. One of them was Brahmagupta. He said, so Aryabhatta he introduced several things, including the place value system, zero plus. He introduced trigonometry. He was the first person to introduce science in the way we know it today. Sine theta, cos theta, if you remember that from your class. Then he also said something that was almost blasphemous at that time. He said that it is not the asterisms. So by the way, he used a geocentric worldview. So for him, Earth was stationary, everything else is revolving. But he did realize that it was not the stars that were moving, it was the Earth spinning like a top. And he said that in a nice little poem, which he says that just like when you are seated on a boat, trees appear to pass by, but in reality you are the one who are moving. It's the same thing for Earth. Now this, people did not like. In fact, Brahmagupta was extremely critical of him. There were others who were critical of him, so critical that none of his students used this model after him. Because they said, if the earth is spinning, we should be flying off. By the way, that's a very difficult problem. It's not that simple a problem as you think. Today we are told that, oh, it's gravity which is holding on us to earth, even though earth is spinning. But this is a more sophisticated problem. You see, earth is spinning, but the gravitational forces are much bigger. They're so much bigger that they totally overpower the centrifugal force due to the spin. In fact, for you to fly off, it can happen, but the earth would have to spin many times faster. And if that happens, even the gravitational force will not be enough. So these realizations, it take almost 1,000 years for us, right? So at that time, it is not against reason that people were not in agreement with him, and people severely criticized him. But it points to one important thing. See, there are two things here. One is Aryabhatta's original work did not survive, but people commented on it. And they commented by giving him credit. They did not say, Brahmagupta did not say, this is my calculation. It is the Aryabhatta who says, this is the way of calculation, I show you this is right or wrong, or something like that. This is very much in the way how we do science today. We call upon the work of others, and then we give them credit, and then sometimes disprove them or prove them right. There was an ecosystem. There was an ecosystem of scholars during the time of Aryabhatta. And this is very, very important. He was not alone. There were many others. There was Varahamira who preceded him, Bhaskaracharya, there were multiple Bhaskaracharyas, Brahmagupta, lot of great mathematicians who kept on. Otherwise, you think a work done around some 500 AD would survive till now? Its original is not there. So the only way it is done is through these citations by people who have repeatedly commenting on the work. So this is a very important problem of ecosystem, because there is one more great event in India's history, and I hope you can see what is, if you recognize what is the architectural structure in the middle of this photograph. Now, this is the sundial, the giant sundial at Jantar Mantar. Yeah. You see, the problem of the calendars had not been solved by the time of Jai Singh. The problem of precision kept on coming. Because of the problem of precision, the calendars every 100 years, they started to drift away. And they were no longer correct. So if they are no longer correct, somebody had to keep on updating them. Somebody had to keep on making new tables for this. Now, Jai Singh, he was later on given the title of Savai, but by not too favorite Aurangzeb himself, he realized this task, and he was a brilliant person. Not only was a great warrior, he fought against the Marathas though. So if you want to have a year with him, bone to pick with him, you do that. But he was a great scholar. He realized that somebody has to address these problems. And you have to redo all the calendrical calculations. He started with using small instruments, very quickly realized that small instruments also have smaller resolution. Things like metal or wood, they change shape during monsoon time, non-monsoon time, heat, cold. And those lead to significant errors that cannot be useful. So he asked himself, what do I do? One answer for him was, make it large. The larger you go, the better the resolution. Another thing is, don't use metal, don't use wood, so use rock. So this is a masonry structure. From what I know, this is the largest masonry sun clock in the world. And in 1700s, he decides to make all these instruments to recalculate the calendars and redo all the calculations. And he creates this amazing set of instruments. Some of them are of old provenance, like something like the sun clock was already known for quite some time. He just made them bigger and made them accurate. How the sun clock works was known to many. But he did create some instruments which seem to be totally his own invention. Because if you look at some of the other ancient archaeological sites where there are astronomical observatories, the ancient, this is by the way, the era of the naked eye astronomy, right? So you are doing everything with your naked eye, everything is alignment based, you are trying to align two stars, two known stars, sun, moon, something to each other and then figure out all the right calculations. So, so Jai Singh so he made all these instruments and he redid all the calculations, which were fantastic. They started to be used by, and he wrote a book called the Jiz-e-Muhammad Shahi, which Muhammad Shah was the Mughal emperor at the time, so he dedicated the year to him. Most likely if he had not dedicated, he would not have given the permission, the funds. Anyway, so that was most likely a political reality for his own times. But he did that, and it tells you that the calendar problem was very, very important. Right? And by the way, there are a set of old archaeological sites where you can find old observatories, naked eye observatories, and this is the most sophisticated of them. There is one in South Korea where there's an astronomical observatory, but that's just a column for observation, just one pillar, sort of, observational pillar. This is far, far more sophisticated. He built 5 of those. The Delhi and the Jaipur one are the biggest. There were 2 smaller ones. One of them is lost. I believe that was one in Mathura. Fantastic work, right? But I call this the scientist's Taj Mahal, not the temple. It is the Taj Mahal. Why Taj Mahal? It's beautiful architecturally. It's abstract. It's weird. You have these abstract forms coming out of the ground. But somewhere it is a monument to the dead, and the death was of naked eye astronomy. You see, this was being built in 1720s. Okay, I finished around 1730s or 40s. But by that time, a revolution had happened in Europe. People had given up on naked eye astronomy, and because of one person who was guilty of that, and that was Galileo. Galileo was the first person to figure out that if you use the technology of the Dutch, who were making spectacles out of glass, if you put 2 of them together in the right fashion, you could magnify. You could magnify, and then you could point it towards the sky and start seeing things that you could never see with naked eye astronomy. This is 1609, his first work, Galileo. So by the time of Jantar Mantar, naked eye astronomy is going to die a really rapid death in Europe. People have given up on it because it simply did not have the power to show what telescopes had. And with telescopes, people saw beautiful things, things that never imagined. They saw the moons of Jupiter. They saw that there was no indication that there would be moons of another planets. And he saw that. But the interesting thing is, not only did he see it, the technology passed on so fast within the scientific circle that everybody started making telescopes. They said, oh, what? Galileo is saying there are moons of Jupiter? No, I'm going to check it. And that's how science goes, right? The first A is to disbelieve a rather incredible claim. So other scientists started making their own telescopes. They started checking, and they said, oh yes, he's right. I can see those moons too. And that's why Galileo became so great. His work was fact-checked while he was still alive. People started seeing a lot of things. They saw the moons of Jupiter. They saw moon more closely. They saw the rings of Saturn. They saw that what they thought was a few stars in some area were full of so many stars that they were uncountable. For the first time, there was this realization that maybe there is something infinite out there in scientific terms. Number of stars, just beyond counting. People also saw, I showed you the nebula picture, right? That was for a reason. People also started seeing other nebulas. The M42 nebula, the Orion nebula, you can see it with your naked eye because it is so big. But there are a lot of other nebula out there which you can only see with a telescope. And they started seeing many of them. Okay. And one such nebula, which becomes an important question, was the Andromeda Nebula. I said nebula, not galaxy. Because see, in that time, people did not know what they were looking at. It seemed very similar. It looked like a wispy, cloudy area where there were some stars. but they did not know how far it was. So interestingly, in 1920s, there was a debate in the US, in Washington, D.C., in the Smithsonian Museum, called the Great Debate, between two big astronomers of that time, Herbert Curtis and Harlow Shapley, if I got the names right. And I forget who claims what, but both of them were wrong on many aspects. But one of them claimed that all these nebula, including the Andromeda Nebula, lay within the Milky Way. And the Milky Way was the entirety of the universe. This is it. In 1920s, this is the state of art. People do not know how far really things are. They're making some estimates, okay, that they're making some estimates of 30,000 light years of Milky Way, but those are very approximate. The other person claimed that no, some of these nebula might be individual universes. They did not use the word galaxy at the time. They said there is an island universes, and Milky Way was one such island universe. The debate doesn't get settled in 1920, obviously, but there was I believe in that audience was Edwin Hubble. And he realized that this is a very, very big problem. He used spectroscopy, and he also used the work of another great astronomer, Henrietta Leavitt, who had mapped some of the stars. And later on, he proves that these are galaxies, indeed galaxies, because they are so far away. So he calculates the distances to some of these so-called nebula. And this is the first time the idea of the universe is kindling in the minds of people, how big it might actually be. Before that, a lot was just conjecture. And, so by 1950s, we understand the Big Bang Theory. We understand that the universe was created, not 1950s, a little bit later, but theories were put forward about the origin of the universe. And this is the time the West is making a rapid ascent in technology. 1960s comes the Cold War, and a lot of things were achieved. First human on moon, first human in the orbit, and a lot of things. 1979, I deliberately put that date as the end date there. Where is India here? Nowhere. It's been missing. It's been missing in action since the days of Jantar Mantar. The Jantar Mantar, you see, was a burial. It was really the death of, in some ways, of Indian astronomy. There were some pockets here and there, but those don't really count that much. Okay, so if everything is dead, what are we talking about? No, there's a very, very bright star on the horizon. Okay, and again, I'm going to do this through another short. So, by the way, this is obviously, everybody knows, Rakesh Sharma, 1984, right? He goes to space, marks a pivotal time for India. This is a very, very unique moment, unique opportunity for India to go to space. But what happens afterwards? Did we send more astronauts? No. Why not? Because we are struggling. You see, the new child of the Indian space program had just been birthed, and there were a lot of struggles. Some of our satellites were being put into orbit, like INSAT 1A was being put into orbit by others. We were making some satellites, but we could not put them in orbit. We had to go to USSR or US to put them into orbit, and we were really, really struggling. By the way, 1984, this was we rode on our friendship with the Russians, but later on in the same decade, we had multiple losses, like SROS 1, SROS 2 were total failures. So Indian space program was not having a very good time in the 1980s. And obviously 1991, what happens? We go into a major crisis, right? So despite the fact that Rakesh Sharma took such an important step for all of us, it was still a lonely step. That was all that happened for Indians in space. After that, it died down, and nothing much really happened after that. Year 2000 onwards, things start to change. People start to dream of slightly bigger projects. And I'm not a historian, so again, I said, some part of it will lived experience to just pat myself on the back. I hope you can recognize, again, the famous guy on the left. No, sorry, the right. That's Annadurai, the mission director for Chandrayaan 1. Chandrayaan 1 was a game changer in the way you have not heard about it. and the way you would not know about it. You know why? Okay, so the story of Chandrayaan-1 goes, this is again by the time we are just achieving some success in the space domain, just becoming confident with satellites, launching something into space. And then they said, okay, this is, we will send a satellite just like some of our other satellites, communication and remote sensing satellites. So it will just go, it is just going to be orbiter and it's going to come back. So there are, by these decisions are not being taken alone. There's a group of scientists who are getting together, having a debate how the mission should be. And Abdul Kalam hears that, oh, this is just going to be orbiter. He doesn't like it. He says, what? No, we want to have an Indian flag on the moon. But we didn't have the capability for a rover at that time. So now, but these are the words of President Kalam. It could not be shaken off just like that. So they said, okay, we will do one thing. We will put together, and this is obviously all the brilliant scientists, including Annadurai, who have to be congratulated for taking the decision. They said, we will put an impact probe. And the impact probe will take some photos, it will just go down, impact, it will be there will be an Indian flag there. So we can say there is an Indian flag on the moon. So this was called the Moon Impact Probe. And on the Moon Impact Probe, they said, okay, since we are sending a probe, let's try to do something more. So they came up with this idea of putting a mass spectrometer. By the way, quick recap. By this time, moon is considered a barren place. 1960s, obviously 70s, there's so much excitement about the moon with the first humans going there, Neil Armstrong and the many others who stepped on that on our moon. There was a lot of expectation at that time. There will be water, there will be rivers, maybe we'll be able to go there and settle as humans. But we only got disappointment. There was nothing there. It was a desert. It was a literal desert. And it has sand, just like a desert. There's no water. Nothing was found. Many missions were flown. Finally, obviously, since there was nothing of value that people could find, there was literally, it is sand. Okay, what is there on the surface? And we know how useful sand is. So the Apollo missions are scrapped. They do fly a lot of orbiters. Nothing of value is seen. And people are slowly beginning to lose interest all over the world about the idea of human colonizations of other places. Chandrayaan-1, again, people don't think much is going to come out of it. In fact, a lot of people question the wisdom of it. Why is a poor country like India trying to send something there? There's nothing there. It's a desert. We have seen it. There's no point. Okay, that's fine, but I'm glad that these people went ahead. They had the blessings of the government. I believe the Atal Bihari Vajpayee government finally gave the green signal for Chandrayaan-1. It flew in 2008. One of the first things they do is they put this Moon Impact Probe, and the Moon Impact Probe lands on the surface. Now, as I said, it was initially thought to be just impactor that will just go and impact, but somebody said, no, I think, and Annadurai being one of them, said, no, we can't just send an impactor. So they put this mass spectrometer. Common terms, mass spectrometer is a very, very sensitive device that measures molecules by their atomic weight and can give very, very precise readings about some atoms in a gaseous state and other places also. It's a very, very sophisticated instrument. But this, by the way, so the impact probe is only going to last 20 minutes. Okay, so it's going to be dropped and it's going to crash, and when it crashes, it's over. In those 20 minutes, the mass spectrometer revealed a fascinating thing. There was a signal at atomic mass 18. What's that? It's water. People were in disbelief. Nobody believed those results. They said, this has to be wrong. You did not calibrate this, which is true. It was not properly calibrated. Some of the measurements were off. The intensities were off. But it was water. Now, interestingly, US had put one more probe on the Chandrayaan-1 called the Moon Mineralogy Mapper. It is called Moon Mineralogy Mapper. It was not sent there for finding water. It was sent there to map minerals. And they looked at the data and they said, could this be right? And this was, by the way, the impact probe is a fully Indian probe. Okay, fully Indian, made by us. And they say, okay, we have to look into it. They recalibrated the devices which were not meant for water, spent months of many scientists poring over data, old data, new data and everything, and they found there is water. Okay? And this was, I'll come back to what I'm showing you here if I have some time. This was the photo that came out of it. You see, there is water near the polar regions. Now, these are not lakes, by the way. Okay, these are not lakes, not rivers, not small pockets of water. These are molecularly thin layers of water on the moon's sand. And this is the South Pole. Now you know why we went to Chandrayaan 3, went to South Pole. Why is it that we targeted it? Because we found water. We are the first one to find it. And this rekindled human imagination like nobody else's business. I'm not going to do this for you, but if you are interested, go and see how many articles were published on water on moon after 2008. How many different probes were sent again and again and again to verify whether this is correct or not. And this gave the human space program all over the world a new dimension. People who were thinking that, okay, moon is going to be a barren place with nothing for us to see, they suddenly had hope. And we know how strong a force hope is. It is so strong that now this entire thing is rekindled with the idea that we have colonies on the moon and the Mars and everywhere else. We started the fire. We cannot step back. So this time when Indians go to the moon, it cannot be just an astronaut. It should be all of us in some way traveling with them. And this cannot be the only one. We must go again and again. Finally, maybe become adventurers all over at once. Right? There was a time when we traveled the seas to all the different countries nearby, and then there was a time when we stopped doing that. It is time to become adventurers all over again. I think, yeah, so maybe I'll just stop here with the hope this astronaut this is our drawing of an astronaut colony. More papers will come out on it soon, but I hope that can be some of us in the future. Okay.
Just one thing for the audience actually. One more thing that Aloke did during COVID is that he recorded a video lecture with his friend for Pondy Lit Fest. We have an online edition that came out during COVID, and that's when, you know, the little thing he's holding there. So the space bricks, he's mad enough to actually use lunar soil simulants and Mars soil simulants to make space bricks with biosedimentation, so that one day we can actually build bricks of the material of the planets and live there. So it's not actually a chimera, it's actually quite happening with this guy. Yeah. So just wanted, you can look up that lecture in PLF 2020 video lectures.
If you want to book a plot, talk to me later.
I just want to say something. Since I was small, I always wanted to become an astronaut and go to the moon. But then I saw the dangers of going, and I saw that it was very dangerous, and I still haven't made up my mind if I'm going to go or not.
It will not be that dangerous anymore. You should think about it by the time you grow up.
This is an open question, I mean, since the subject is space. So, very recently, the Indian government privatized the space technology companies and the businesses and entrepreneurship to come up. But it has not really taken off in a very big way, at least as expected. So, what is your view on that? Is it like a key to the future? And what is really blocking that to become a big force? And what is the future in that area?
Okay, so first and foremost, it's a very necessary step. Without privatization, without some things being taken up by the private enterprises, will go nowhere. space remains a difficult place because it is very capital intensive. The rates of failure are very high. You need people who will put in money and have the risk appetite, which for India sometimes it doesn't happen. The venture capitalists, etc., they want their returns very fast. But we have still, despite all that, we have seen good progress from Skyroot, companies like Skyroot, Bellatrix, Agnikul. So we are, despite all these challenges, we are still doing not that bad, but it could be better, but I think it will become in some time. But it's a very, very crucial pillar for our space program.
So when the Western countries were developing, ways to map stars and discovering the astronomical world, we know about their conquest. Like we know that they sailed seas and use that knowledge in order to travel and explore places. So anything parallel to India's development back in the days when we were discovering everything about the space that you can mention, like some of our conquests and what we have achieved parallelly by using the knowledge that we have gained of the stars.
So when you talk about navigation, that relied almost entirely on naked eye observations, and India was far ahead in that, which is probably why we had such a good maritime, some empires which were very good in navigation that went to a lot of places. We are extremely good at it. We were one of the pioneers. There were others also, but Indian astronomers were very sought after. As I said, in around 600 AD in China, there were monks from India who traveled there, became royal astronomers because you needed them to do all the calculations. So we are really, really far ahead. But by the time of the Jantar Mantar, I'm using that as a sort of a marker, things have gone down because we did not adopt the telescope. That doesn't stop the navigation problem. That does nothing to the navigation problem, but it did something to our understanding of the universe. We did not gain knowledge about the universe at the same rate as the others.